Hi everyone, my name is Robert Sumatragay and I will be discussing the um, strength requirements on Philippine Electrical Code Part 2. So let's begin. Okay, general. Preliminary assumption. So it is recognized that the formation, deflection, or displacement of parts of the structure may change the effects of the loads assumed. So if we if we use a materials that is been deformed or been deflected, so that the loads may change, and in the calculation of stresses, allowances, and maybe for such deformation, deflection, or displacement of supporting structures, including poles, tower, guys, crossing pins, conductor, fastening, insulators, when the effect can be accurately evaluated. Such deformation, deflection, or displacement should be calculated using the rule 3.6.1. So we can see that rule on the slide. Loads prior to application of the overload factors in rule 3.6.4. Again, we can see this rule in the next slide. For crossing or conflicts, the calculation shall be subject to mutual agreement. And another one is this: recognize that new materials may become available while these materials are in the process of development. They must be tested and evaluated. Trial installation are permitted where qualified supervision is provided. So we can be replaced this if we have the authority to or the supervision of our that he or she will provide a if she permit the installation, so we can provide um, the replacement. Alright. So another one is the application of strength factor. So for this, we have the structure shall be designed to withstand the appropriate loads multiplied by the overload factors in Article 3.6. You can see this in the next slide or maybe soon. Okay, without exceeding their strength multiplied by the strength factors in Article 3.7, unless unless otherwise specified, a strength factor of 0.8 shall be used for the extreme wind loading. So 0.8 uh, is the factor that will be used for the wind loading condition. Okay. So another one is the grade B and C construction. So we have supporting structures. The strength requirements for supporting structures may be met by the structure alone or with the aid of guys or bases or both. So we have here a metal press stress and reinforced concrete structure. So number one is the this structure shall be designed to withstand the loads in roll 3.6.3 multiplied by the appropriate overload factors in table 3.6.4 dash 1 or dash 2 without exceeding the permitted load. Number 2 is the permitted load shall be strength multiplied by strength factors tables 3.7.2.1 or dash 2 where guys I use. Okay. So number 3 is the all structure including those below 18 meters shall be designed to withstand without conductors the extreme wind load in load 3.6.1.2 applied in any direction on the structure. Number 4 is the splice and reinforced structure. Reinforcement or permanent splices to supporting structure are permitted provided they develop the required strength of the structure. So for the wood structure, we have a table here. Wood structure should be of material and dimension to meet the following requirements. Our wood structure should be designed to withstand the loads in, you can see this in the rule 3.6.3, multiplied by the appropriate overload factors and table without exceeding the permitted stress level. So we have here a table This is the grade B, this is the grade C. So for the metal and precious concrete structure, uh, is to 5. So we have our grade B will be using a 1.0 and grade C is 1.0 also. And for the wood and reinforced concrete structures, 2.3. So we have a 0.75 for grade B and also grade C is 0.75. So support hardware is 1.0 also, grade B and C. Our guy wire 4.5 is 0.9 and the other one is 0.75. I don't think this is 0.75. I think it's 0.9 also. This can I think this is 0.9. You can assume that this is 9. Okay. For the guy anchor foundation, is to 5 is 1.0 and grade B and also grade C. So exception, number 1. When installed, natural ground wood poles acting as single base structure or unbraced multiple post structure shall meet the requirements of rules 3.7.2.1 B section 1 and 3.7.2.1 B without exceeding the permitted stress level and the ground lines for unguided poles or at the points of attachment for guide poles. So exception number 2 is at a grade B crossing in a straight section, wood structure complying with the transverse strength requirements of rule without the use of transverse guides shall be considered as having the required longitudinal strength, providing the longitudinal strength is comparable to the transverse strength of the structure. Exception does not modify the requirements of this rule for dead ends. Mm, okay. Another table is for the 10 factor use with loads. Okay, for the wood and reinforced concrete structure, grade B is 1 and grade C is 1.0 also. So exception 3. At the grade B's crossing the supply line over a highway or communication mm, line where there is an angle in the supply line, wood structure shall be considered as having the required longitudinal strength if all of the following conditions are met. So number 1 is the angle is not over 20 degrees. And the angle structure is guide in the plane of the resultant of the conductor tension. So the tension in this guy under the loading in rule 3.6.3 multiplied by an overload factor of 2.0 shall not be exceed the rated braking strength multiplied by the strength factor. So the our angle structure has sufficient strength to withstand without guys the transverse loading of rule 3.6.3 multiplied by the um, this is the appropriate overload factors in this table, so, which would exist if there were no angle at the structure without exceeding the permitted stress level. Okay, so permitted stress level. Um, okay, is the natural wood poles. The permitted stress level of natural wood piles of um, various species meeting the requirements of ANSI or ANSI 0.5 1 to 1992 shall be determined by multiplying the designated fiber stress set forth in the standard by the appropriate strength factors in table. Okay, so A is the sawn or laminated wood structure member, cross arm and braces. The permitted stress level of sawn or laminated wood structure member, cross arm and braces shall be determined by multiplying the appropriate ultimate fiber stress of the material by the appropriate strength factors in table. Okay. For strength of guy poles. Guy poles shall be designed as columns, uh, resisting the vertical component of the tension in the guy, plus any other vertical loads. Splice and stub reinforced poles. Reinforcement or permanent splice at any section along the pole are permitted provided they develop of the required strength of the pole. For the average strength of three poles, so a pole of a single base structure not individually meeting the transverse strength requirements will be permitted when reinforced by a stronger pole or each side if all of the following are met. So number one, now our one is the average strength of the three poles meets the transverse strength requirement. So the weak pole shall have not less than 75% of this required strength. The sag and tension of the wires, conductors, and cables in the adjacent spans shall provide adequate additional support for the weak pole, and the average of the span does not exceed to a 45 meter. So, for the exception one is the span may exceed 45 meter but shall not be greater than 91 meter. If overhead guys are run between the three poles and the line section is head guide and back guide, an extra pole inserted in a normal span for the purpose of supporting a service drop may be ignored in this strength determination. So exception to is the rule. This rule does not apply to crossing over railroads, communication line, or limited access highway. All including those below 18 meters shall be designed to withstand without conductors. The extreme wind load in Rule 2.6.1.2 applied in any direction on the structure. Transverse stand requirements for structure where side guying is required but can be installed only at a distance. So grade B. If the transverse strength requirements of this article cannot be met by the use of side guides or special structure and where it's physically impractical to employ these side guides. The transverse requirements may be met by side guiding the line at each side of a near practical to the crossing or other transverse to weak structure and the distance between such guide structure of not over a 250 meter. Provide that the side guide structure for each such section is of 250 meter or less shall be designed to withstand. Calculate transverse load due to wind on the supports on the entire section between side guide structure. So the line between such side guide structures shall be substantially in a straight line and the average span between the side guide structures shall not exceed 45 meters. So the entire section between the structure of required transverse then shall comply with the highest grade of construction concerned in the given section, except except as to the transverse end of the intermediate poles or towers. Okay, for grade C, the above provision do not apply to grade C. So longitudinal is the strength requirements for section of higher grade lines of a lower grade construction. Methods of providing longitudinal strength and our grade So grade B is the longitudinal strength requirements for section of line of higher grade in lines of a lower grade. So for assumed longitudinal loading, C rule 3.6.3 may be met by replacing a structure of this required longitudinal strength at each end of the higher grade section. Where this is impractical, the supporting structure of the required longitudinal strength may be located away from the section of higher grade within 150 meter on each side and with not more than 250 meter with not more than 50 meter between the structure of the required longitudinal strength. This is permitted provided by the following condition. So longitudinal loading, we can see this in the rule 3.6.3, may be met by placing a structure of the required longitudinal strength at each end of the higher grade section. So where is this impractical? The supporting structure of the required longitudinal strength may be located away from the section of higher grade within 150 meter on each side and with not more than 250 meter between the structure of the required longitudinal strength. This is permitted provided the following conditions are met. So you can see that this been a done for grade C. For grade C, so extent of foundation settings and guy anchors. So foundation settings and guy anchors shall be designed or be determined by experience to withstand the loads specified, multiplied by the overload factors in table, without exceeding the permitted load. The permitted load shall be equal to the strength multiplied by the strength factors. So strength of guys and guy insulator. So the strength requirements for guys and guy insulator are covered under 3.7.5 and 3.8.1 A subdivision respectively. So for metal pressed concrete structure, guy shall be considered as an integral part of the structure. So and for the wood and reinforced concrete posts and structure, when guys are used to meet the strength requirements, they shall be considered as taking the entire load in the direction in which they act. The structure acting as a structure only, except for those structures considered to possess sufficient uh, rigidity rigidity so that the guy can be considered an integral part of the structure. Okay, now we go to the cross arms and braces. So concrete and metal cross arm and braces. Cross arms and braces shall be designed to withstand the load and rule 3.6.3 multiplied by the overall factors in table. You can see that table in the next slide or next. Without exceeding the permitted load shall be equal to the strength multiplied by the strength factors in this table. Wood cross arm and braces. For the strength, cross arm and braces shall be designed to withstand the load specified in rule 3.6.3 multiplied by the overall factors in table without exceeding permitted stress level. Okay. The permitted stress level of solid sawn or laminated wood cross arm and braces shall be determined by multiplying their ultimate fiber stress by the strength factors and materials and size. So wood cross arm and braces of select southern pine or Douglas fir shall have a cross section of not less than those in table. Cross arm of other species may be used provided they have an equal strength. Dimension. We go to dimension of cross arms section of select Southern Pine and Douglas Fir. So you can see this is a grade B in millimeter, grade C in millimeter also. So cross arm length is millimeter. So if we have a 100,200 millimeter or below or less, we use for grade B 75 by 100, and in grade C we use 70 by 95. So if we use 2450 millimeter, we use for grade B is 82 by 108 and 75 by 100 in grade C. Also in 3000 we have 82 by 108, and also in grade C we use 75 by 100. So cross arms and braces of the other materials. So cross arms and braces should meet the strength requirements of rule in this rule. So additional requirements: longitudinal strength. General is the cross arm shall be also be designed to withstand a load of 3.1 kilonewton applied at the outer conductor attachment point without exceeding without exceeding the permitted stress level for wood cross arms, or the permitted load for cross arms of other materials as applicable at each end of a transversely weak section. As described in rule, the longitudinal load shall be applied in the direction of the weak section. So methods of meeting rule. So for the grade B, where conductor tension are limited to a maximum of 9 kilonewton per conductor. Double wood crossarm having cross section as specified in table, and properly assembled with comply with longitudinal strength requirements. For grade C, this requirement is not applicable. Location is at crossings. Cross arms should be mounted on the face of a pole away from the crossing, unless special bracing or double crossarm are used. So bracing, crossarms shall be securely supported by bracing. It is necessary to support safely all expected loads to which they may be subjected, including line personnel working on them. So double crossarm or brackets. For grade B, where pin type construction is used, double crossarm, each crossarms having the strength required by this role. So, or a support assembly of equivalent strength shall be used at each crossing structure. At ends of joint used for conflict section, and at dead ends, and at the corners where the angle of departure from a straight line exceeds 20 degrees. Under similar condition, where a bracket supports a conductor operated at more than 750 volts to ground and there is no cross arm below. So double bracket shall be used. Exception. Exception is the above does not apply where communication cables or conductors cross below supply conductors and either are attached to the same pole. Okay, or where supply conductors are continuous and of uniform tension in the crossing span and each adjacent span. This exception does not apply to railroad crossing and limited access highways except by mutual agreement. So for grade C, the above requirement is not applicable. So insulator. Okay, insulator. The stand requirements for insulator cover under rules. The stand of pin type or similar construction conductor fastening longitudinal strand general, pin type or similar construction and ties or other conductor fastening shall be designed to withstand the applicable longitudinal loads in Rule 3.6.3, multiplied by the overload factors in Table 3.6.1 at 3.6.4-1 or 3.1 kilonewton applied at the pin. Whichever is greater method of meeting roles. So for grade B, where conductor tension are limited to 9 per kilo and such conductor are supported to pins insulator, double wood pins and fixed or their equivalent will be considered to meet the requirements of roller. So grade C is no requirement. Okay, at ends of higher grade construction in line of lower grade. So for grade B, pins and ties or other conductor fastening connected to the structure and at, at a dead end or at each end of the higher grade section should be designed to withstand an unbalanced pull due to the conductor load specified in Rule 3.6.2 multiplied by the overload factors. So for grade C, this requirement is not applicable except for dead ends. So at ends of transverse section described in Rule 3.7.2.1 section C. So grade B, pins and ties or other conductor fastening connected structure at the ends transverse section are described in Rule 3.7.2.1. So and C shall be designed to withstand the unbalanced pull direction of the transverse section under the allowed in rule, multiplied by the overload factors in table 3.6.4-1. So for grade C, we have no requirements. So double pins and conductor fastening. So for grade B, double pins and conductor fastening shall be used where double cross arms or brackets are required by rule 3.7.2.4. So shall be designed to withstand the unbalanced pull in the direction of the transverse section under the load in rule 3.6.3 by multiplied by the overload factors in table 3.6.4.1. So grade C, no requirements, double pins and conductor fastening. So for grade B, double pins and conductor fastening shall be used where double cross arms or brackets are required by this rule. So exception. So the above does not apply where communication cables are conducted across below supply conductors and either the attached of the same pole. So where the supply conductors are continuous and the uniform tension in a crossing span and each adjacent span. So this exception does not apply in the case of railroad crossing and limited access highway crossing except by mutual agreement. So for grade C, we have a no requirement. Okay, for single supports used in lieu of double wood pins. So a singular conductor support and its conductor fastening when used in lieu of double wood pins shall have strength equivalent to double wood pins and their conductor fastening as specified in this rule. So armless construction. So we have a general of open conductor armless construction is a type of open conductor supply line construction in which conductors are individually supported at the structure without the use of cross arms. And insulating materials. The strength of insulating materials shall meet the requirements of Article 3.8. So other components. Strength of other components shall meet the requirements of Rule 3.7.1 and 3.7.2. Okay, open supply conductors and overhead shield wires, so sags and tensions. The supply conductor and overhead shield wire tension shall be not more than 80% of the rated breaking strength for extreme wind loads in Rule 3.6.2. So multiply by an overload factor of 1.0. The tension in at 15 degrees Celsius without external load shall not exceed the following percentages. of the conductor rated braking strength. So initial load tension is 35%. The final unloaded tension is 25%. So exception. So in this case of the conductors with the generally triangular cross section, such as cables composed of the three wires, the final unloaded tension at 15 degrees Celsius shall not exceed 30% of the rated braking strength of the conductor. So splice stops and dead ends, fittings, and associated attachment hardware. So splice should be avoided in crossing and adjacent spans. If it is impractical to avoid such splices, they shall not be stressed beyond 80% of their rated braking strength under the extreme wind loads of this rule. So multiplied by an overload factor of 1.0. Excuse me. Taps should be avoided in crossing spans, but if required shall be of a type that will not impair the strength of the conductor to which they are attached. So dead ends, fittings including the associated attachment hardware shall have sufficient strength to withstand the maximum tension resulting from extreme winds loads of Rule 3.6.2. Dead ends fittings shall not be stressed beyond 80% of their rated braking strength under extreme wind loads of this rule, multiplied by an overload factor of 1.0. So trolley contact conductors. In order to provide for a for weak neutral contact, where or weak neutral contact conductor should be installed of less size than 50 millimeters squared millimeter if of copper or 22 squared millimeter of silicon bronze. So supply cable messengers. So messengers shall be standard and shall not be stressed beyond 80% of their rated braking strength. Under extreme wind loads of this rule multiplied by an overload factor of 1.0. So open wire communication conductor. So open communication conductors in grade B or grade C construction shall have the tension and sags 3.0 in rule 3.7.2.8 for supply conductors of the same grade. So exception, when supply conductors are truly contact, conductors of 0 to 100 0 to 750 volts to ground 3.5 millimeter dash SDL may be used for communication conductors or for spans of 0 to 30 meter, and 14 millimeter STL may be used for spans of 3,800. I don't think this is of 45 meter. Communication cables. Communication cables are no strength requirements for such cables supported by messenger. So you can see this in rule 3.7.2.11. For the strength requirements for messenger supporting communication cables, okay, the messenger shall not be stressed beyond 80% of their braking strength under extreme wind loads of rule 3.6.2 multiplied by an overload factor of 1.6. Okay, for the paired communication conductors. Paired communication paired conductor supported on messenger. So use of messenger is a messenger may be used for supporting paired conductors in any collocation, but is only required for a pair of conductors crossing over truly contact conductors more than 7.5 kilovolts to ground. So the sag of messenger. Messenger used for supporting paired conductors required to meet Grade B construction because of crossing over truly conductors shall meet the SAG requirements for grade B. Size and SAG of conductors. So there are no requirements for paired conductors when supported on messenger. Paired conductors not supported on messenger. Above supply lines. So for above supply lines, we have grade B, the size and SAG shall be not less than those required by rule 2.7.2.8 for supply conductors of similar grade. For grade C, sizes and SAG shall be not less than the following. So this spans is 0 to 30 meter, no SAG requirements. Each conductor shall have a rated braking strength of not less than 0.75 kN. And for the spans to 30 to 45 meters, sizes and SAG shall be not less than required for grade B communication conductors. So span exceeding 45 meter, sizes and SAG shall be not less than required for grade C supply conductors. So above truly contact conductors. So for grade B, sizes and SAG shall be not less than the following. So the span 0 to 30 meter number such requirements shall be not than less than the SAG for 8.0 square millimeter hard drawn copper. So the span exceeding 30 meter, each conductor shall have a rated braking strength of not less than 0.75 kilonewton. SAG shall be less than the SAG for 8.0 square millimeter hard drawn copper. For grade C, sizes and SAGs shall be as follows. So the number one is the spans to 0 to 30 meter, no SAG requirements. Span exceeding 30 meter, also no SAG requirements. For grade C, each the conductor shall have a rated braking strength of not more than 0. Kilonewton, not less than 0.75 kilonewton. So support and attachment hardware. The strength required for all support and attachment hardware not covered by this rule in this rule shall not be less than the load times the appropriate overhead factor given in this rule. For appropriate strength factors, see rule 3.7.1. So rules on grade D. This grade D construction are not used in this edition. So grade N construction. The strength of grade N grade N construction need not be equal to or greater than grade C. So our poles used for lines for which neither grade B nor grade C is required shall be for initial size and guide or braces to withstand all expected loads, including line personnel working on them. So for the guys, the general requirements for guys are covered in this rule. So cross arm strength. Cross arm shall be securely supported by bracing, if necessary, to withstand all expected loads to which they may be subjected, including line personnel working on them. Okay, for the supply line conductors, we have the sizes. Supply line conductors shall be not smaller than the sizes listed in this table. So sizes for grade and supply line conductors. So this is the type of conductors. We have a copper, medium or hard drawn copper, steel, EC, ACSR, alloy, and ACAR. So for the urban span, 45 meter or less, we have measurement here in square millimeters. So for the copper, we have 14 millimeters squared. So for rural, spans exceeding, this is for exceeding 45 meter. So also in square millimeters. So in rural, we use 8 millimeter squared. So For medium or high drawn copper, we use 8, and also in rural we use 8. So for steel, we use 14, and 14 also in rural. So standard aluminum. So for AC, we use 22. For urban and for rural, we use 30. So ACSR, we use 14 and 22 in rural. For alloy, 22 square millimeter in urban, and also 22 square millimeter in rural. For ACAR, 22 square millimeter in urban and 30 square millimeter in rural. So service trap. Sizes of open wire service trap. So not over 750 volts. Service trap shall be as required by rules. This rule A and B below. So the spans not exceeding 45 meter. So sizes shall not be smaller than those specified in table in later table in the said table. So spans exceeding 45 meter shall sizes shall be not be smaller than squared 8 square millimeter. So exceeding 750 volts. So sizes are of service drops of more than 750 shall not be less than the required supply for light conductors on the same voltage. Okay, we have here the sizes of service drop of 750 volts or less square millimeter. So for the voltage of truly contact conductors wire are voltage to this group. So we have a alone we the soft drone is 5.5, the medium or hard drone is 3.5 copper wire. So for steel is 8, and the AC aluminum wire is 22. The concern with communication conductor is 5.5, 3.5 for the medium hard drone. Steel wire is 8, AC aluminum wire 22. So oversupply conductors of 0 to 750 volts, we use 5.5 for the soft drone copper, and 3.5 for the medium hard, hard drone. So for steel wire, uh, 8 and 22 for the aluminum. So 750 volts to 8.7 kilovolts. We use 8 uh, for soft drone, 5.5 for the medium, 8 for steel, and 22 in aluminum. So exceeding 8.7 kilovolts, we use 14 soft drone, medium is 8, and 14 for the steel wire, and again 22 for the aluminum wire. So over through the contact conductors. So 0 to 750 volts AC or DC is 8. We use 8 for soft drone, 5.5 for the medium, 8 for the steel, 22 for the aluminum. So exceeding 750 volts AC or DC. So in soft drone we use 14, 8 for the medium, 14 for the steel wire, and 22 for the AC aluminum wire. So tension of open wire service trap. So the tension of the service trap conductor shall not exceed the strength of conductor's attachment of for or its support under the expected loads. So cable service traps. So service conductors may be grouped together in cable provided the following requirements are met. For the size of each conductor shall be not less than required for drops of separated conductors. So tension of cable service strap. So the tension of the service strap conductor shall not exceed the strength of the conductor's attachment to or its support under the expected loadings. So truly contact conductors. So in order to provide to with truly conductors shall be 60 square millimeter or greater if copper, or 22 square millimeter of silicon bronze. Communication conductors. There are no specific requirements for grade A communication line conductor or service strap. So street and area lighting equipment. So for the lowering rope or chain for luminaires, range to be lowered for examination or maintenance shall be of a material and strength designed to withstand climate and climatic condition and to sustain the luminous safely. Okay, for the insulators. So the strength requirements for insulator are covered under rules 3.8.8 and 3.8.10 guying and bracing. So where is this used? So when the loads are greater than can be safely supported by the structures alone, additional strength shall be provided by the use of guys, braces, or the other suitable construction. Such measures shall also be used where necessary to limit undue increase of sags in adjacent span as well as the provide sufficient strength for those supports on which the loads are considerably unbalanced. For example, commerce angles, dead ends, large differences in span length, and changes of grade of construction. So for the strength, guys shall be designed to withstand the loads in rule 3.6.3. So multiplied by the overload factors of in table 36.3.6.4-1 without exceeding the permitted load. The permitted load shall be equal to the strength multiplied by the strength factors. So for guy wires conforming to ASTM standards, the minimum breaking strength value therein defined shall be rated breaking strength likewise in this code. Okay, point of attachment. So the guy or brace should be attached to the structure as near as it's practical to the center of the conductor load. To be sustained, however, on lines exceeding 8.7 kilovolts, the location of the guy or of brace may be adjusted to minimize the reduction of the insulation offered by a non-metallic supports arm and supporting structure. So for the guy fastening, so the guys having the rated braking strength of 9.0 kilonewton or more and that are subject to small radius bends should be standard and should be standard by suitable guy timbers or their equivalent. Any guy having a design loading of 44.5 kilonewton and or wrap around cedar or similar softwood poles should be protected by the use of suitable guy shims. Where there is a tendency for the guy to slip of the shim, guy hooks, or other suitable means of limiting the likelihoods this action should be used. So shims are not necessary in the case of supplementary guys, such as storm guys. So guy markers and protection. So for the ground and of anchor guys exposed to pedestrian traffic should be provided with a substantial and conspicuous marker. So where an anchor is located in an established parking area, the guy shall either be protected from vehicle contact or marked. Nothing in this rule is intended to require protection or marking of structural components located outside of the traveled ways of railroads, of roadways, or established parking areas. Experience has shown that it is not practical to protect structure from contact by out-of-control vehicle operating outside of established traveling ways. So, electrolysis. So, where anchors and those are subject to electrolysis, suitable measures should be taken to minimize corrosion from the source. So, anchor rods. So, anchor rods should be installed so as to be in the line with the pole of the attached guide when under load. So, exception. is not required for anchor rods installed in rock or concrete. So the anchor and the rod anchor assembly shall have an ultimate strength not less than the required of the guy by this rule 3.7.5.2. Okay, that is the end of my discussion. So thank you for listening. If you have any question, uh, you can email me in this email address or contact me. Thank you for the time. And, keep safe, everyone. Thank you.